into the variable day, and then you can print day. Then Tuesday gets put into the variable day, and then the statement gets executed. Then Wednesday gets put into the variable day, and then the statement gets executed, and so on. Okay. And you can see here, as you might expect, Monday, Tuesday, Wednesday, Thursday, Friday gets printed. And here are a couple more ways you can try this out. So we can actually loop over a string and we can get back characters from the string. So for every character in the string, we print out the character. So here Monday becomes MONDAY. We can loop over a tuple or a list. This is more of a list than a tuple. So here we are going to loop over the list apple, banana, guava, and then we are going to print it out saying here's a fruit. So here's a fruit, apple, banana, and guava. We can loop over a dictionary as well, which is again something that we will do a lot over the course of the next few lectures. So here we have a dictionary, and then we are going to use the name John Doe, sex male, age 32, married. And then when we loop over a dictionary, what we get back is just the keys. We do not get back actual values from the dictionary. So if you want to access the value, so here's what we do, right? So for key in person, and then we are going to print out the key. So the key is going to have the values name, sex, age, etc. And then if you want to get the actual value stored against that key, then you simply pass the key into the dictionary using the indexing operation, right? So the person key, when key is name, will give you the name, and so on. So let's run this. And so you can see here the key is name and the value is John Doe. When the key is sex, the value is male. The key is age, the value is 32. The key is married, the value is true. And that's all it is. If you do want to iterate over actual values, then you can just call the .values method on a dictionary. So person.values will now give you a list of values, and now you see we have just the values. Or if you want to get back both keys and values, then there is also something called .items, and then .items is going to give you both the key and the value. All right. So that's our for loop. With the for loop, we can iterate over a bunch of different containers, but sometimes you might want to iterate over simply a bunch of numbers, right? You might want to run something, you might want to run a loop from, let's say, numbers from 0 to 100 and then perform certain operations using those numbers. And that is where you can use the range operator, the range function. So here are a few examples. So if you just say for I in range 7, so when you say range 7, or any range n, that creates a sequence of numbers from 0 to n-1. So range 7 creates a sequence of numbers 0 to 6. You can see that here, if I print it out, that's going to create the range of numbers from 0 to 6. You can also specify a start index and an end index. So what you can do is you can say range of 3 to 10. So what that does is that starts with 3 and then goes all the way up to 10, but not including 10. So that becomes 3, 4, 5, 6, 7, 8, 9. So you can see 3 to 9 get printed here. And finally, you can also give a step. So here we start with 3 and we go all the way not equal to or greater than 14. So we can go all the way up to 13, but we take increments of 4. So we have 3 and then we have 7 and then we have 11, and then 11 plus 4 becomes 15, which is greater than or equal to our end index. So that is not printed, right? So this is pretty useful. A range is pretty useful when you also need access to, let's say you want to go over a list, but you also want to know within the for loop which element in the list you're accessing, right? The index of the element. So that is when a range is useful. That let's say if you're going over a list, here you have the list of days. What you can do is you can create a range with the length of the list. And then you have the index I that goes from 0 to the length of the list -1. So 0, 1, 2, 3, 4 are going to be the indexes. So you can then print that the value at a position 0 is Monday and the value at the position 1 is Tuesday, because we are formatting the string and we are putting in I, the value of the index, and then we are getting the element with that index out of the list. All right. So that is the range function. And similar to while loops, for loops also support break and continue statements. So anywhere within a for loop, if you feel like, okay, you should probably end this loop right now because maybe you found what you need of the loop. And similarly, here is the continue statement. So here you can see that beyond Wednesday, we do not process Thursday and Friday. But In the same way, if we were printing things out and we were simply doing a continue, then what happens is that when we reach Wednesday, this statement becomes true. So we print, I don't work on Wednesdays, and then we say continue. So this print statement below gets ignored. All right. So here with continue instead of break, we say today is Monday, today is Tuesday. I don't work on Wednesday, but we still process Thursday and Friday. So those are the break and continue statements. And finally, this is not very common, but sometimes you may want to just create an empty loop, nothing inside a loop. So you just say for day in weekdays, and then you say pass. So if you say pass, nothing happens. You simply go over all the elements, but nothing really happens. Now that's it about loops that we'll cover right now. You can nest for and while loops inside each other. So I leave that as an exercise for you to try out. You can nest for loops inside while loops. You can have if conditions inside for loops, inside while loops, and so on. But again, even just as with the conditions, if you nest too many loops, it can become difficult to read and understand. So you may not want to do more than 2 levels of nesting within a loop. Okay, that's all the discussion that we have about variables, data types, and branching and loops. And then I'm going to go back to lesson 2. And now we're going to look at a very interesting topic, something that is at the very core of programming, and that is the idea of functions and scope. Okay, so open up the notebook. Let me just click run on Binder. Wait for that to get started. All right, so let's just go full screen and let us hide the toolbar. So I'm just going to do kernel restart and clear output. Okay. So we've already seen some functions, right? We've seen the print function, we've seen the len function, we've seen the data types related functions, which can convert data types from one type to another. And then we've seen methods as well. But just to recap, a function is basically a reusable set of instructions. There is some logic which you think can be used again and again on different data, or needs to be, you do not want to write the same set of code each time you want to do that, perform that operation. So you convert it into a function, and a function takes one or more inputs, performs certain operations on those inputs, and then often returns an output as well. Okay. And Python provides many built-in functions like print, len, and so on, but you can also define your own functions. So this is a print function, pretty straightforward. We've seen this, but here are the inputs. Today is, and then today, that is an input as well, which becomes Saturday. And then the print function simply performs an operation which is displaying the input on the screen. It does not return anything. Okay. Python allows us to define our own functions as well. So what we can do is we can define a function, let's say called say hello. And now the say hello function can print hello there, and the say hello function will print how are you. So it's a pretty straightforward function. The way to do it is def space function name, and then you have these parentheses or these round brackets. Inside it you can put some inputs, but we're not doing that just yet. And don't forget this colon character. And then the body of the function needs to be indented by 4 spaces, just like the body of a for loop, or just like the body of a while loop or an if statement. Okay, so that's a function has been defined. But when you define a function, the statements inside the body are not actually executed, and that's why you do not see anything printed here. So once a function is defined, you need to invoke it, or you need to call it. So that's the same thing. You will hear invocation, you will hear function call, you will hear function execution. It all means the same thing. So the way to invoke a function is to call the function name. So just type the function name and then pass these brackets. So an open bracket and close bracket, that is used to invoke the function. And you can provide any inputs here as well, but our function does not take any inputs, so we're not going to do that. And then we just run say hello, and that is going to print out hello there and how are you. Let's try it again. So if I run it again, it once again prints hello there and how are you. And that is really the key benefit, that now I only had to write it once, and now I can use it with a single line. I do not need to type out the code again. Okay. But just functions which do not take any inputs are not very interesting. So functions can also accept one or more values as inputs, and sometimes you will see them referred to as arguments or parameters. And there are some technical differences, but ultimately these words are used quite interchangeably. And so we'll go with the word arguments because that's the most common thing that you see used. So arguments to a function help us write flexible functions which can perform the same operation but on different values. Okay. So for instance, we'll create a very simple function and then we'll see this function that is already there. So here we have a function say hello, and we will let it accept a name, and then we will print hello, and we will do a string formatting, and we will pass in the name. Okay. So if we just say hello to John, that says hello John, and say hello to Jane, and that says hello Jane. So just taking that idea forward, here is an example of a function. It's called filter even. What it takes is that it takes a list of numbers, a number list as an input, and then it does certain things, and then it returns an output. Okay, so there's an input going on here, and then there's some operations being performed here, and then there is a return statement. So I'll tell you what this operation, what it does, and I'll not go over the code exactly, but what it does is it takes the list of numbers and it only keeps the numbers, it only retains the numbers that are even. All right, so the result list will contain simply the numbers out of list which are divisible by 2. And the way it does it is it loops over the number list and it checks whether that number is divisible by 2 or not. And if the number is divisible, it appends it to result list and then returns the result list. Okay, so let's try it out. So here, and by the way, the return a function returns, to return a value, you simply say return and then pass the variable or the value that you want to return. And what you can do now is we can invoke filter even with a list of values, and then we can take this output of filter even and put it, so use an assignment operator to assign the output of filter even to the variable even list. All right, so we have 1 2 3 4 5 6 7, and then we have the even list. So you can check that now the even list only contains 2 4 and 6. Okay, and now you can take the same filter even function and then you can run it with a different array, let's say 1 3 5 7 9, and this time when we run it we get back the empty array or the empty list, I'm sorry. Okay, so those are functions, and then now we have functions with return values. So the next thing we want to look at is how to write great functions in Python, because as a programmer you will be and you should be spending most of your time writing and using functions. The more functions you write, the better you get at programming, because you then learn to structure what you need to do into small functions that you can reuse in different ways. Okay, and we are going to explore how to write a great function and using the many features that Python offers, and we'll do this by solving a problem. So let's see. So here is the problem that we'll try and solve. So Radha is planning to buy a house that costs $1.26 million. So $1,260,000. And when you buy a house that's so expensive, you have to probably get a loan. So she's considering two options to finance her purchase. So she has one option, which is to make an immediate down payment of 300,000. So she just pays 300,000 right now and then take a loan, an 8-year loan with an interest rate of 10%. So a loan has a duration. The duration is 8 years. You have to repay it in 8 years. And there is a certain interest that you pay. So there's a 10% per annum interest rate. So I should probably just put in per annum here. Okay, so there is a 10% per annum interest rate. And then there is a 10-year loan, which has an interest rate of 8% per annum. Okay, so she can either take out an 8-year loan for just the remaining amount if she pays 300,000 right now, or she can take out a 10-year loan with an interest rate of 8% for the entire amount. Now, both of these loans have to be paid back in equal monthly installments, also known as EMIs. So now what we want to figure out is which of these two loans is going to have a lower equal monthly installment. Okay, and this is the problem we'll solve, and then we'll build this function step by step. So we'll also see how to build a good function, and we'll use certain features of Python to make it very flexible and powerful. Okay, so the simplest thing that we can do is, since we have to compare EMIs, we need to calculate these EMIs or monthly installments for both of these loans. So it'll be helpful to define a function so that we do not have to type out the same logic for each of these loans. All right, so we're going to define a function called loan EMI, and to start with, we're going to simplify it a lot. We're just going to say that, okay, you just give us the amount, and we'll assume that there is no down payment, there is no interest, and the loan has to be paid back in exactly 1 year in monthly installments. Okay, so we simply take the amount and then we divide it by 12, and that gives us the EMI, and then we print out the EMI, okay, using the print statement. So our loan EMI function just takes one input. So here we call loan EMI with 1.26 million as the input. So you can write it like this: 1,260,000, or you can also just say 1.26, which makes us 1.26 multiplied by 10 to the power of 6. So that is 1.26 million. Okay. So if you take out the entire amount you want to repay in 12 months, then this is the amount that you need to pay per month. Pretty simple, straightforward. That's fine. So now let's add a second argument. So let's, apart from the amount, let us also include the duration of the loan in months. So after what time are you going to completely repay the loan? So you have the amount, and then you have the duration in months. So we put in the duration here, and all we need to do is divide the amount by the duration. And once again, we're just going to return the EMI. Okay. So we've just extended our function a little bit, and step by step, we're going to just make it better. Now, one thing I want to note here before we actually use this function is that you will see that I have actually created a variable called EMI here. Now, where does this variable live? Because if you try to access this variable, let's say I try to access EMI, it says the EMI variable is not defined. And it's not, if I call the function, it will become defined. Let's say if I just call loan EMI with 1.26 E6 and with a duration of 10 years. So that is 10 times 12. So we need the duration in months. So the function has been executed, but even now the EMI variable is not accessible. Not only the EMI variable, but even the amount and the duration. Okay. So even if you try to access these, they are not accessible. And that is because these are all local variables within the function, right? So a function, when you define a function, within the function, there is a scope, and all these variables which are used inside the function are only available within the function, and they are called local variables. So scope is basically the rules that define where a certain variable is visible. So if you have a variable that was defined outside in a separate code cell, that is a global variable. You can access it anywhere in your code. And then if you have a variable that is defined within a function, that is a local variable. Okay. And that's a very useful thing to have, because now you can define, let's say 5, 10, 15, 20, 100 functions. In each of these functions, you can use the same variable names without worrying about what you do with the variable in one function inside a function affecting the value inside another function. So each of these will get initialized from scratch inside the function. So that's just a little note on scope. Okay. So now we can compare a 8-year loan with a 10-year loan. For the 8-year loan, we pass in 8 into 12, those many months. And for the 10-year loan, we pass in 120 months. We still are not considering the down payment. So you can see that the EMI obviously for the 10-year loan will be smaller than that for the 8-year loan, as you might expect. Okay. And now this is great. We can see visually that these values are different, but it would be nice to compare them as numbers. And maybe we want to calculate the difference and so on. And that is where we can actually use a return value. Let's modify our loan EMI function now. And this time what we are going to do is we're going to return the value of the EMI. So we're going to say EMI is amount divided by duration, and then return the EMI as a value, as an output. Now when we call loan EMI on 8 years, we can actually take the output and then put it into an EMI1 variable. And then we can then go for EMI2 and take the value of the 10-year loan and put it into EMI2. So now we get an EMI1, EMI2, and we can now take a difference of these two, and we can check, okay, there's a difference of $2,000 between the two EMIs. Again, right now we are not considering down payment or interest, but it's a good thing to see how things are evolving. Okay. So next up, let us add the down payment, the immediate down payment, the amount that you're going to pay right now that needs to be deducted, and the rest of the amount is what you need to take the loan for. Now, since the first loan has a down payment, but the second one does not, what we can do is we can make this an optional argument with a default value of 0. So now we still have the amount, we have the duration, but we have the down payment, and the down payment has a value of 0. So now the loan amount becomes amount minus down payment. And now the EMI becomes the loan amount divided by the duration, and then we return the EMI. So here when we have an optional argument, we can invoke it just as a normal argument. So here we say we pass in the loan amount, we pass in the duration, and then we pass in the down payment. That's the first loan, the 8-year loan with a down payment of 300,000. And now we get back a $10,000. We get back $10,000 EMI. But on the other hand, here what we have is we've just passed in the loan amount and we just passed in the amount and duration, and we've not passed in a third argument. So when we do not pass it in, Python takes and converts this. Python simply uses the default value, down payment equals 0. So the loan amount simply is the whole amount, and hence you get back the EMI for the second loan. Okay. So optional arguments, very useful to have, makes your functions very flexible and easy to use. Okay. So next, now let's add the interest into the calculation. And this is the part you may have been wondering, how are we going to calculate interest? How are we going to introduce that? And we're just going to use a formula here, and it's not a very difficult formula to derive. You have a little bit of math like arithmetic progressions and such, but I'm not going to go into the derivation of this formula. I have linked to a video if you're really interested in understanding how it works. But the idea here is to get the equal monthly installment, we take the loan amount, which is also called the principal, and then we multiply it with this expression. So we multiply it with the rate, and this rate needs to be the rate of interest per month. So note that the rates that we are given are in per annum. We multiply it with 1 plus r. So that's 1 plus the rate raised to the number of months, right? The number of periods that we want to talk about. And then we divide the whole thing by 1 plus r to the power n minus 1. Okay. Again, it's just a mathematical formula, and we simply need to convert that into Python code. So let's do that. So now once again, we are going to introduce, we have the amount, we have the duration, we have the rate, and then we have the down payment. Now one thing to notice here is that all the required arguments in the function, the arguments that have to be specified, have to come before the optional arguments. Because what happens is, otherwise if you invoke loan EMI with 3 arguments, Python may get confused whether you're trying to refer to the down payment or you're trying to refer to the rate if down payment is before rate. So remember to keep all of your optional arguments at the end of the function definition. So once again, we take the loan amount, that is the amount minus the down payment. Then we have the EMI, which is the loan amount multiplied by the rate multiplied by 1 plus rate raised to the power of duration. And that's why we took the duration in months. And remember, the rate has to be monthly as well. And then we divide the whole thing by 1 plus rate raised to the power duration minus 1. All right. So that's our loan EMI function. And we are getting there. So now we have the down payment, now we have the EMI, now we have the rate of interest, and now we have the duration included as well. So now when we talk about the 8-year loan, we pass in the duration as 8 multiplied by 12. And then we pass in the rate. So the rate was 10% per annum, which is 0.1 and 0.1. So the monthly rate becomes 0.1 divided by 12. So that's what we've put in here. And this was the down payment. And that gives us back what the EMI looks like, around $1,456.7, $14,000 per month. And then similarly for the second option, we simply put in the amount and then the duration and the rate, no down payment, and then we get back the EMI value. Okay. So now this is good. And now we have already answered the question. So we can see that option 1 has the lower EMI. So that's good. Radha can now decide what to do. But if you look at this function call, it's not looking very pretty. It's not easy to tell what are all these numbers that you're putting in here. In fact, it would be really easy to make a mistake here. I could very easily, if I do not remember things correctly, I could just put in this here, and then that would still give me a result, but that would be a completely false result, right? This is completely wrong. So the way to avoid that is to use something called named arguments. Okay. So while invoking a function with many arguments, it can get confusing and there can be human errors. So what you can do is you can specify the name of the argument before the actual value that you pass in. So you can say loan EMI, and then I have written out each argument on a separate line, and you can do that. You can split the function invocation into separate lines, but you don't have to. You can write it all on the same line as well, as I've done for the second case. But the key idea here is you can type the name of the argument, then put in an equal to, and then put the value in. So this can be a value, this can be a variable, this can be an expression. Like here, this is an expression, 8 multiplied by 12. Here is the rate, and then here is the down payment. Okay. So that looks much nicer. Now and by the way, when you do that, you can actually change the order of arguments as well, because you're specifying the name. So you can actually put duration before, you can put duration before the amount and so on. So that's the EMI one. So that's about one, you get the same result, no change, even though I changed the order of the arguments. Then we have EMI 2. This is for the loan without the down payment, the 10-year loan, 8% rate of interest. And once again, we get back the same result. Okay. So this is fine. This is good. But if you see this, I don't like this whole 10 characters of 10 digits after the decimal, because normally you're going to, pay back whole dollars. So what we might want to do is we might want to round this up to full dollars. In just a second. Yeah. So we might want to round this up to full dollars. And what you can do is you can maybe write a function. You can write a function called round up. Okay. And that takes a number X, let's say, and then try to figure out what you can do here. So try to figure out what you can do here, round it up and return the result. And you can use this function inside the loan EMI function. So functions within functions, using functions within functions is a very powerful technique. You can try this out and it'll be a good exercise. But since this is such a common thing, rounding numbers up and down, Python provides a built-in function for it, except that this built-in function is part of the Python standard library. So because there are a lot of, Python is a general purpose language that is applied to many different use cases in scientific computing, in data analysis, in software development. So it doesn't make sense to just put all these functions into the global namespace, because that is going to just put in tens of thousands of function names into our global namespace. And every time you try to declare a variable, it might collide with a function, or your known function names might collide with functions. So what Python does is it puts them into modules, right? So modules are nothing but files containing Python code. So they can contain variables. So these are files with a .py extension, and then they can contain variables, functions, classes. And what they do is they give you a way of organizing large Python projects into files and folders. And the key benefit that modules offer is namespaces. That is, when you want to use something from a module, and we'll see an example very quickly, you need to first import the module, and then all the methods, all the functions, everything inside a module will have to be accessed using the name of the module. So that makes sure that your global namespace that you're working with does not get affected. And that allows people, like if you have 20 people or 100 people working on a project, everybody can write their own modules and they can use the same variable names, they can use the same function names, and that will not cause problems when you want to use those modules together. Okay. So here's and by the way, you can write your own modules, but we are going to use some built-in modules from the Python standard library. Okay. So I'm going to import the math module that contains a lot of math related operations. And inside the math module, there is a function called ceil, C-E-I-L, which stands for ceiling, which basically takes a number and then rounds it up. So if I want to know what the ceiling function does, I can simply call help on ceiling. And here it says the ceiling of x as an integral is what it returns. It takes a single value x, and it is the smallest integer that is greater than or equal to x. So that's exactly what we want. So now to invoke this function, we say math.ceil, and that rounds up 1.2 to 2. Okay, so that's great. So now let's update our loan EMI function to, it is the same function as before: amount, duration, rate, down payment, get the loan amount minus down payment, calculate the EMI using the formula, and then call math.ceil on EMI and then store the result back into EMI. So this is just going to do that rounding up. And now if we calculate the EMI, you can see that 14568 is the EMI for the first option and 1515288 for the second option. So we can compare these EMIs or equal monthly installments now, and then we can print a nice message which Radha can view. So you can imagine you're building this system where people can put in a bunch of loan options, and then they get back whichever is the best or whichever has the lowest EMI or whatever they want to optimize for. And yeah, and that's it. So that's one way of just using functions, and we've built this function step by step, and we've made it better over time to answer this problem. Okay. But apart from just answering this problem, what we have achieved here is actually we've created a fairly generic function that can be used to solve many other similar problems. And now we do not have to think of that entire logic. Like we do not need to remember the formula. We do not need to figure out how to round things up and so on. So let's try a couple more problems and let's see how easily we can solve them using these functions. So here Sean is currently paying back a home loan for a house he bought a few years ago. So Sean has a loan of $800,000. The loan has a duration. The duration was a 6-year duration, and the loan has a down payment of a